All right, well, I'm going to get started here. And so welcome to our seminar series. This is the Introduction to the Climate Resilience Network. We are a project that's funded by the university as part of the Grand Challenges Fearlessly Forward initiative that President Pines and Provost Rice initiated a few years ago. And we wanted to share with everybody the work that we're doing. And also to stimulate a little more excitement, perhaps, on some of the work we're doing, and also to maybe build some collaboration. So I'm Ralph Ferraro. I'm the PI for this project, and our first speaker is going to be Mike Maddox, who is the project manager. So our plan is to try to have one of these a month. The first one's going to be an overview of the general types of topics that the project's doing. And then we're gonna, each month we're gonna have one of the investigators as part of the team focus in on the type of work they're doing. So just a few words about Mike. So Mike's a senior faculty specialist at the University of ESSIC, the Earth Systems Science Interdisciplinary Center. Got his degree in natural resources. University of Maryland School of Agriculture. Okay, I'll keep going. Mike's been at Essex since 2007. He was brought on as part of a project called the Chesapeake Bay Forecasting System. And he was focused in on some of the agricultural parts of basically hydrological modeling. He also been involved in several different projects, one including something with the Smith School about supply chain studies for supply chain studies that were associated with climate change. He also did some exploratory work in support of NOAA with there was the Cygnus mission, trying to see if that satellite instrument could look for standing water over land. Let's see what else. He's been involved with the NASA Climate Assessment Team, looking at teleconnections between sea surface temperatures and precipitation. He also, last summer, he did the AMS, last winter AMS Climate Policy Colloquium program. Learned a lot about how things worked, or maybe used to work. And then he's also been involved with the Professor Liang's project, the Dashboard for Agricultural Water and Nutrient Management, called DAWN. And again, he's been for the Climate Resilience Network, our basic program manager and outreach coordinator, and he's touched base with quite a few stakeholders as part of this project. So I'm gonna turn it over to Mike, and we'll look forward to his talk.
I was gonna wear a remote and wander around, but since I don't have a clicker, I don't have somebody working the slides, it kind of takes it away, so I can't use the whole floor space like I'm supposed to. So welcome to the first seminar for the Introduction to the Climate Resilience Network. Like Ralph said, this is going to be the 50,000 foot view. I can't go into a lot of detail on everything, but I'll try to touch on a lot of the work we do. Just about this series, like Ralph said, it's every month. Our next one is going to be Michael Humber from Geography. He's going to be going over what he's been contributing to the, it's too late to set that all up. He'll be going over what Geography has been contributing to the Climate Resilience Network, which is pretty interesting work they do with climate and agriculture. And everybody is welcome to come to these, federal, state, whatever, students, faculty, staff, straggler on the street, whatever. So why are we here? For our grand challenge, we basically made the proclamation that there was a societal need to address challenges, especially in Maryland and the Chesapeake Bay region, related to extreme weather, agriculture and food security, and air and water quality. We happened to win one of the institutional grants which funded us up and through this June. And these pictures, the one on the right is my neighbor's backyard. The one on the left is a field in Somerset County, and the other one is Baltimore during a rainstorm. So what do we do? So our philosophy is research for an impact. We're not necessarily trying to satisfy the scientific curiosity as much as we're trying to solve a problem within our community. And we try to do that by bringing together the different unique resources that a university offers that the state or county might not have access to. And we also are trying to provide quite a bit of learning for students and a place for students to learn how to do science and how to work with the community and stakeholders. Our full team, our leadership team, you met Ralph Ferraro. There's also Timothy Canty, he's from AOSC, and he also is the director of MEES, which is the Marine Environmental Sciences Science graduate program, which is actually all the Maryland campuses. James Farquhar from Geology, Tatiana Laboda from Geography, Sumant Nigam, that I always get wrong, from AOSC, and Lars Peter, and we're just gonna leave it there. He is our director at ESSIC, Earth Systems Science Interdisciplinary Center. I'm not even gonna try to, I've known Lars for probably better of a decade, and I'm still not going there. Our team, so Mike Maddox, that's me, research and stakeholder coordinator. One of our senior advisors is Louis Uccinelli, who used to be the director of the National Weather Service. He works a lot with the Hydronet and other aspects of the project, and he brings a lot of expertise and a lot of just historic knowledge of how some policies were written and how the Weather Service works and how NOAA works. And when you need to make a phone call, his phone calls get answered. So if I try to call somebody, maybe not, but when Louis calls, they respond. Kazi, she's not here, but she's a communications and website and coordinator. Jennifer Collins is our experiential learning coordinator, and she's a former science teacher and former graduate of the Geology School at the University of Maryland. So she has a science background and experience in the classroom before she joined us. And our key investigators are Russell Dickerson from AOSC. Russell Dickerson, hey, now I know why your name's not there, Tim, because you're up top. Russell Dickerson, James Hyde, and Ed Strobach. And from Geology, there's Karin Prestegard, Sujay Kushal, Monghan Hung, and Geography is Michael Humber and Kara Mobley. Mobley. So getting into it, our agenda's gonna go air, land, and sea. So we're gonna start with air. So one of the things that the Resilience Network does is we bring people together, not necessarily that we fund research or we have some big bucket of money that we're finding things to do. We get people together to collaborate to solve problems. So this is one of the collaborations that we were able to kind of foster, and this is with AOSC and the CAT laboratory, which is, they do a lot of traffic work across the nation, especially in the state of Maryland. They have incredible data. They have incredible data visualizations. But basically, anytime they monitor the traffic in the state of Maryland. So anytime a truck goes over one of the rolling way stations, they know it. They take a picture of it. We have all the data. They have traffic flows. They do all kinds of analysis, which allows, they gave us that data, and that allowed AOSC, Russ Dickerson and his team, and James Farquhar to work with that data to estimate emissions. So black carbon, carbon monoxide, your nitrogens, and your hydrocarbons. Also, that data was provided to the Max Planck Institute, and they have a tool where they model ultrafine particles. And what's an ultrafine particle? So it's a pollutant. It's less than 100 nanometers wide. They have major health impacts, but they're short-lived in the environment. But these particles are so small, when you breathe them in, they actually absorb into the vesicles of the lungs. There's no getting them out. There's no filter. There's nothing you can do about it, really. So on the community scale in the urban areas, they are very dangerous and play a major role. And part of the CAT Lab's data and AOSC and Max Planck working together is helping to solve this problem. What else do we do in air quality? If you've ever been through the Baltimore Harbor Tunnel, there's a big pile of coal sitting at the CSX Curtis Bay facility. So our researchers, along with Maryland Department of Environment and Johns Hopkins, asked the questions, when is there dust? Where did it come from? What direction does the wind blow? How big are the pollutant particles? How long does it last in the atmosphere and how far can it travel? I mean, in the picture, you can see the Curtis Bay residential core is basically one street away from the warehouse and the coal. And there's a playground within a half mile, maybe 3/4 of a mile of that gigantic coal pile sitting there in Baltimore. So because of this work, for the renewal of the permit that CSX got, they have to put up wind screens and enhance their water spray system so that there's not as much dust floating around. And that was directly because of the work that was done by Russ and his team. If you look at the Baltimore Banner, you can find articles on that. Animal production air quality issues. So there are somewhere around 1 billion chickens processed through the state of Maryland and Delaware in a year. That's a lot of chickens. And they produce a lot of ammonia, a lot of hydrogen sulfide. So in those areas, it's a nuisance, but it stinks. Also, those chemicals, when they get into the atmosphere, they can create acid rain back from the 70s and 80s. They do a little time travel. So what our team's done with Johns Hopkins is they've set up some sensors, tested some sensors, and now they're putting them in place on the Eastern Shore to find the hot spots around these combined animal feeding areas. So what other air quality work do we do? Can I knock that out? What is that? Anyway, we'll get back. Come on. Go down. So we're working in the city of Cheverly, which is nearby. Use an electron microscopy looking at the particulate and the air pollution in Cheverly. A lot of our team is on the Maryland Climate Change Commission or works directly with them, including Tim Canty. And I think Russ is on that commission as well, or at least consults with him quite a bit. A picture of my favorite car in the world, it's Noah's Ark. It's the air resource car. I love that thing. Basically, working with NOAA, we can commission a study where they drive the car around neighborhoods or wherever and take readings of a couple different types of air pollutants and give us a real-time map of where it's concentrated and not concentrated. And then on the other picture is flights that we've done looking at methane and CO2 over the Chesapeake Bay and the Chesapeake Bay region. So that's the type of air quality work we do. So working with traffic emissions, working with greenhouse gases, working with other institutions, working with the communities to make people safer. Come on. Moving on to land. So the geography department, Michael Humber and Kara Mobley, is it Mobley or Mobley? Mobley. They created this awesome dashboard, the Maryland Agricultural Climate Impact Dashboard. It looks at sea level rise, coastal flooding, drought, temperatures, erosion, soil vulnerability, groundwater availability. It's made in ArcGIS, so there's story maps. So whenever you hit a tab, you get a story about the background, and then you have different data points and layers that you can click on and off. I would do a live demonstration, but Michael Humber has always warned me about doing live demonstrations. So I just have some screenshots on the next page. I will not do a live demo. So this is just a couple of screen grabs. So the one with the Chesapeake Bay in the yellow, those are salt patches that were detected by remote sensing. And the pink is from 2011, and the yellow is from 2017. So you can see how it has increased over just 6 years, the difference in the salt patches. And why is that important? If there's salt in the soil, your commercial crops won't grow. So your corn, your soybeans, strawberries, watermelons, whatever, any salt in the soil, and it pretty much just kills the agricultural potential. And we already have 1 billion chickens to feed. So where are they getting that food from? They're shipping it in from the Midwest, they're shipping it in from China, they're shipping it in from India to feed the chickens. So now instead of having local crops, you've increased all the transportation and all the fun stuff that goes along with transportation, like, burning diesel fuel, putting soot in the air, CO2, CH4, all that fun stuff. On the right, it's kind of a data visual dashboard, so you can look at, this one's for 2025 for corn, but this one you can look at your leaf area index, how's it doing versus historical, your precipitation versus historical. It gives the farmers a good look at how this year's going versus last year, and then they can drop down any year they want to and see, what did 2024 look like? What did 2023 look like? This work comes to us through the NASA Harvest Program, because Michael Humber is also the assistant director of the NASA Harvest Program. So we kind of borrowed this information and this tool from them, and they included it in our dashboard. We also can collaborate with the Maryland Department of Agriculture. So this spring, they invited us to one of their lead seminars, and lead is leadership, education, and development. So the Department of Agriculture through the state has these classes every year where they teach agricultural practitioners how to be leaders in the field. So we were fortunate enough to go present there at Maryland at the headquarters in Annapolis. So we have pictures of Michael and Kara, since they're not here, and myself presenting different tools and dashboards to them. They were very interested. What else are they doing? They're coordinating some small stakeholder workshops for us this fall. They're participating in our 2026 workshop in January. They're coordinating meetings with agriculture advisement companies in the state of Maryland, so they can look at our tools and see if they want to invest into them for the future. And they're also going to be providing us a climate and agriculture priorities document this fall. So the Maryland Department of Agriculture's climate priorities looking forward. And one of the projects that they're actually very interested in is using the remote sensing capabilities of the Geography Department to examine solar panels on prime farmland. Maryland just passed a bill capping solar development on prime farmland. It's one of these like chicken and egg arguments, I guess. Solar is good, but so is growing the crops locally and not transporting them. So, I think you can take both sides of that argument. On the Western Shore, they're doing a lot of this agrivoltaics, where a lot of people are putting in solar panels and then raising sheep, because sheep don't jump, goats jump, and cows are big enough to push it over. They also, the Geography Department also is working with their NASA Develop internship to do some of that work. All right, getting on the water. So this is work that's done by Karen Prestegard and her group, the impact of climate change on floods and droughts in Maryland. So what's the problem? The problem is that the precipitation, the variability is changing. You're getting these short-term storms that are intensifying. It leads to higher runoff, lower groundwater. It increases floods and these kind of mini droughts that occur between them. And it's especially bad in urban agriculture areas. On the graph, the blue is catchments in urbanized areas or shallow bedrock, where you get these really high runoff rates. But then the bottom graph is showing that there's low groundwater storage. Why is that a problem? Well, the problem is that during these mini droughts, you just don't have the water availability in the groundwater. So maybe the wells are going dry, maybe streams are going dry, or there's just not enough water to continue some of the uses that resources have provided before. And they've been installing stream gauges in pretty small streams to see how they react to the hot and dry conditions and to the intensity. And they've also been using the federal gauges to look at the climatology, the long-term effects on climate and runoff. So on the right, this is, I believe that's Greenbelt. Is that Greenbelt? This is what it looks like when you get incision from these high intensity precipitation events and you have high runoff because you have impervious areas and you have channelized flow, and it just completely erodes the soil underneath of it. And on the left-hand side, this is a study that she did with one of her graduate students or postdocs. I can't remember. He's in transition, I think. But you can see in the southeast United States, you have these increasing clustering where you're getting these very intense events, but you're not getting as many of them. And that leads to the decreasing base flow, and decreasing base flow means you have lower water levels. So like if you were in the Rappahannock water basin and you wanted to put in, 15 million square feet of data center and you need water, you get into this big water rights fight that they're having right now because the people that use the water from the Rappahannock right now don't want to give up those water rights. And Virginia wants to put a data center. Basically, they should be able to walk across the state from roof to roof on data centers. Did I say that out loud? Oh yeah, I forgot about that. Yeah. Nobody uses the Monocacy River. Freshwater salinization. If you haven't heard of this topic, you should kind of look it up. This is Sujay Kaushal. He really specializes in this. He's pretty much one of the world leading experts in this, I would say. And it's by talk, so I get to say that. So what's the big deal about it? It affects your safe drinking water. It affects ecosystem health. It corrodes the infrastructure, and it can damage food production because if you're irrigating with salted water, you're going to kill your crops. And if you remember Flint, Michigan, big news, well, probably 7 or 10 years ago now. The problem with Flint, Michigan wasn't anything besides they'd never checked the salt content of the water when they switched sources. The new source had more salt in it. That salt reacted with the old infrastructure and released a bunch of heavy metals. So if you remember from chemistry, you have a periodic table, you have sodium, you have chlorine. If anybody ever threw a block of sodium into a tank of water, which you're probably not allowed to do now because of safety regulations, but it basically explodes when it hits water. Super reactive. Chlorine, super reactive. So when you get those in large concentrations, they basically make this biogeochemical soup that can form some pretty nasty organic particles that can react with your industrial solvents and your soaps. Some of them you can't filter out. So if you think about your drinking water and something like the Potomac River, and you think about all the road salts and everything that are coming downstream, it can be a pretty challenging environment to think about. And speaking of drinking water, one of the things that we funded through the Climate Resilience Network was looking at Watts Branch, which basically drains Rockville in Montgomery County. And Watts Branch feeds into the Potomac River about 1 mile above the Washington Sanitation and Suburban Sanitation Commission's intake for water for the Washington, D.C. So you're draining Rockville, all the salt and everything that comes from Rockville, right into the WSSC intake. And up until recently, they were not monitoring for salt. So it goes through the system, it goes through everybody else's systems. It can cause some problems. And also some of Sujay's working in the Chesapeake Bay is the first one that tracked salinity and the tidal rivers and over time. So he's been working with the Chesapeake Bay program for a salt management program for the state of Maryland. This is Monhong. This is advancing. So basically he uses non-invasive methods with geophysics to look at groundwater and water table depths. So he uses LIDAR, ground penetrating radar, resistivity, things of this nature. And combining all that information, all those systems, he can look at the porosity, he can look at the saturation, he can look at your groundwater table. So in steep structures or steep mountains or really any kind of inclines of any magnitude. The traditional way to do this is to drill a bunch of holes. Well, it's kind of impractical on the side of a mountain to drill a bunch of holes. So he's tested this in Puerto Rico. He's tested this in California, and now he has a research site that we funded in Clarksville at the farm there, where he's testing these methods so that they can be used anywhere in the state of Maryland instead of doing a bunch of drilling and penetration testing. Hydronet. So this was a project that was born from asking the question to a bunch of stakeholders, what do you need? No. Basically, at one of our conferences, one of our researchers held up a sensor and said, I can bring this to you, I can put it in your neighborhood, and it'll tell you what the sea level is right there in your neighborhood. You don't have to worry about a sensor that's 50 miles away. You'll have the information right at your hand. We asked who wanted it, and every hand in the place went up, basically. So that was the birth of the Hydronet. I've been working heavily with in that project, installing the sensors. These pictures are from our groundbreaking in Annapolis 2 years ago now, I think. So working with these stakeholders, they want to know where it's going to flood. And you say, okay, that's great. We can tell you where it's going to flood. We have these NOAA sensors in the bay. Well, they want to know if it's going to flood on that street or that street. And if you don't have the data at that fine spatial resolution, you can't make the models or the predictions at that fine level. So what we do is find communities that are having trouble and need this. We go in and we install a dense network, and we can help them work on making these fine scale predictions and help them be a little more resilient to flooding. So I kind of already spoke of this. The map on the left is where sensors were located in the Annapolis area, which there was really only one. So we went in, we have 5 in the Annapolis area now. And I just looked at it before I came over here. At 2 a.m., it's probably going to flood. Unless the wind patterns shift before then. But the wind patterns don't look like they're going to shift until later. The little graph there is just to prove to people that the sea levels are getting higher. Why? We don't care. We just know that they are. And we provide the data and information to the communities to help deal with that. And then the map on the bottom, the blue is where we have installed sensors, and the yellow is where we've had communications with people to put sensors in. In October, Cecil County is getting 4 sensors. And this fall, Calvert County is getting 4 sensors. We already have sensors in Charles County, Anne Arundel County, Chrisfield, and Ferry Cove. The Mesonet. So this is funded by the Maryland Department of Emergency Management. It's kind of, we've kind of taken them under our umbrella a little bit. Maybe we should, but basically why a Mesonet? What is a Mesonet? Mesonet means middle. So historically, if you looked at a weather forecast and you were in, I don't know, say College Park, you were looking at a forecast that was generated by data from National Airport, PWI Airport, Dulles Airport, Philadelphia Airport, maybe College Park, maybe the police station has a weather station that reports, maybe it doesn't. But generally the weather service is relying on these big systems that are installed. You know, they're expensive, they're big, they're heavy to maintain. So they're installed at airports where you actually really need to know exactly what's going on, but to look at data from Somerset County or Charles County, you know, with thunderstorms, you could rain in my neighbor's yard and not rain in my yard. So the Mesonet is basically going in and filling in those gaps. So these are weather service grade systems, but they're not as big as the weather service. And they're funded by MDIM and James Hyde, who's pictured here. He's on campus. He's a faculty member and he's in charge of the Mesonet program. He's not in the building with us today. What do they measure? Basically everything you need: air temperature, pressure, humidity, wind speed, direction, radiation, rainfall, snowfall depth. One of the unique things is they're measuring soil moisture and temperature at 5 different depths. So at every one of these stations, the soil moisture, it is actually very valuable for the flooding, for us to understand why it's flooding some places and not other places. And you can see the size of the station that they're putting in. But the other nice thing about these is they're actually feeding this data real time to the Weather Service. So the Weather Service is incorporating them into the forecast models, which should enhance the forecast in our area and make it a little more accurate. Is it accurate or precise? A little more precise. No, accurate. Accurate was right. Oh, you get that wrong. I always get that one wrong. Experiential learning and outreach. So one of our key tenets to this was to make sure we included students, and we were educating the next set of scientists that come after us. So since 2023, there's been over 100 students in the intern program. They get a paid 10+ week internship. They work directly with a mentor. Geography launched the high school internship program in 2023. So this is an internship program for advanced high school students. We also work with the Cooperative Institute for Satellite and Earth System Studies, which is actually underneath of ESSIC or inside of ESSIC, with their interns program. So what do the interns do? They do research just like any postdoc or graduate student would do. They do field work. They do, fundamental research. They do experiments. They do lab work. They learn what it is to be a scientist. And some of this is in coordination with the senior projects that they do in atmospheric and ocean sciences. And it's open to all Maryland students. And the top right is, he's an intern. This is Jake. And he did an internship on communicating climate change. And on the bottom, that's myself with the mayor, Chris Field, with 2 of my interns, Maria and Amelia. I know, Amira. Their names are actually, what is that? Anagrams, Maria and Amira. Anyway, they studied extreme tidal flooding and its effects on harmful algal blooms around the city of Crisfield over the summer. And they actually stayed on with me for the year and are still working on that project. Another project that's not necessarily totally under us, but we work a lot with is mesoterps. And this is a student-led project in AOSC. They install the Micronet. What is the Micronet? And they monitor the Micronet. The Micronet is a series of small weather stations that are installed around campus. If you look on the bottom right, that was the rainfall rate last night. So that big spike is Munching, and you can see the rest of them. So when I talked about why we need weather stations beyond just the airports, so this is just on campus. Munching was getting 2.4 inches of rain per hour, and the rest of campus was less than ½ an inch of rain per hour. Assuming that those were actually working. And also they communicate the weather conditions. They actually do a weather forecast or weather synopsis every morning on their website. Sometimes we'll get in the green screen room and actually act out being a weather forecaster. But the mesoterps, it gives the students a chance to work in the field and understand what it's like doing this kind of work every day, close up, instead of just learning from a book. And the website is all them. So the website weather.umd.edu, that is the mesoterps. Hydronet, we also have a Hydronet student group. They do website development, case studies, so they look at Tropical Storm Debbie when she came through. They did a case study on why it flooded at Annapolis and what were the meteorological conditions around that. They work with communities. We have them building sensors now, hopefully. They have to present their work to stakeholders. So I know Ava had to present to Maricus. She did a webinar with Maricus is a regional group that's funded by NOAA. It's the Mid-Atlantic Regional Association of Coastal Ocean Observation Systems. It's a mouthful. And I can tell you what it is later. And working with policymakers. So on the left, you got Senator Van Hollen was toured Crisfield with us with a group, and you got Ava and Katie, who were two of our students, were on that tour with us, and you got to meet Van Hollen and talk to him. And then another picture of my interns meeting with the mayor of Crisfield. And so our interns do real work, our students do real work, they meet real people. This is not like, go to the library and get me a book job. Outreach stakeholder workshops. So in January of 2024, well, in the fall of 2023, I said, hey, why don't we have a workshop? That'd be cool, right? Let's bring some people on and talk to them. So in January 2024, we had about 50 people show up to ESSIC. We had a lot of our co-PIs did little lightning talks, and we had these open discussions. So it wasn't death by a million PowerPoints. We talked to 50 different stakeholders or groups that came, people from the state, some federal, some communities. And that went really well, and they all said they loved it. So in 2025, we did a 2-day workshop that had over 125 participants. The provost gave the keynote. It was a series of focused open panel discussions. We had presenters from CMNS, AGNR, BSOS, and BMGT. So we expanded from just our group to multiple colleges across campus. And that was very successful, so there will be another one coming up, and I'll announce that later. And we learned some lessons, and we learned what to focus on and what to pursue in the future by having these workshops. Some of the stuff we do K through 12, we partnered with some environmental education centers. So Nanjemoy Creek is Charles County Public Schools, Smithsonian Environmental Research Institute Center, which is in Anne Arundel County, Annapolis Maritime Museum. And what kind of stuff do we provide? So our former teacher has come up with, she has lesson plans, she has little stories of how to present some of this information, tricks and for teachers, teaching outside, teaching climate change, how to claim and evidence-based learning. We have a picture on the right is one of our sensors at the Nanjemoy Environmental Education Center. So they have the sensor there. They work directly with the data, doing data analysis and looking at tide levels and tidal anomalies and things of that nature. We also do some infographics, and hopefully it showed up big enough in here. A little blurry. Coastal flooding. We have some other ones, but this is just an example of the work. So this is designed for like middle school kids to learn, what's a watch, what's a warning, what's an advisory, what causes coastal flooding. I mean, I think if you asked most adults walking around today, what is a watch, an advisory, or a warning meaning from the Weather Service, they would have no idea what the difference is. So we're trying to involve ourselves in some of this education. And then the other picture is, it's the back of we're developing a playing card game that helps with environmental education. It's basically based off of Gin Rummy, where you have a problem, a cause, and a solution. You have to match them all up to make a book. And it's basically passive learning. You're looking in your hand going, coastal flooding is caused by blah, 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 blah. So, and that background was designed by one of our students that works for us. She's awesome. She should have been a graphic designer, but she decided to be a AOSC major, which is awesome for us because we have a graphic designer. So what's on the horizon for us? So we're trying to work on a data system for environmental data that incorporates everything that we generate in our network and some of our partner data so that there's one central place to go. If you've worked in the Maryland region and you've tried to find data, even on the Chesapeake Bay program site, you find a lot of dead ends. You'll go and you say, oh, this is perfect. This is exactly what I want. And it's from 2009 to 2017. And then the project ends and you're like, okay, well, where's the data? Anyway, so one of the things we're trying to do is work on this document exchange and this data. And there's a little bit of a screenshot of what we've been working on right here. But this will be open to the public to go in, search documents, find out information, find data, download data, and our partners are going to be welcome to put data on there. We need to start streaming more sensor data to NOAA. This is specifically Maricus, which we've already gone over before, but Mid-Atlantic Regional Association Coastal Ocean Observation Systems and the National Weather Service. We're working on developing a sensor lab where we're going to build some of these sensors in-house. We have an oyster aquaculture tour that's on the books coming up. And this is Ferry Cove Oyster Hatchery. It's a very high-tech, advanced oyster hatchery where we're going to tour and learn about what the water quality issues are that they need, what the weather, so that we can help them, scope out the data and scope out where they should put their oysters and where they shouldn't. This is new, partnering with the Smith School and UMES to integrate flood modeling and insurance. And we're acquiring a GNSS space station and RTK rover to survey sensor locations and elevations, which we will share with partners and do work for other people for. But basically what this will allow us to do is go put a sensor in and we can go tell you exactly where it is, X, Y, and Z on the Earth. So we can relate, if you have a sensor network, you know exactly the elevation of all of them so you can relate them all to each other. This is just some of the places we go and the people we meet. This is me in DC. I'm way here on the end at the policy colloquium. This is President Pines and Amitabh and Tim Canty looking at one of the sensors. She was a senator at the time, but Sarah Elfrath, who is a congresswoman now. This is in Northeast Maryland. I just had to take a picture of that sign because it's pretty awesome, but we're putting a sensor in there. And just some of the people we've met around town and around the place. And this is our coming up, our Climate Resilience Network Scientists Serving Communities 2026, January 20th and 21st. If you go to this website, you can save the date and you can also give us some feedback on what topics you'd like to see featured or anything else. And that is our show for today. If you have any questions, please go ahead. I'm probably pretty fast because I talk really quick. It's not bad. There's got to be somebody that asks a question. You're going to use the catch box.
How can you raise your hand? I don't see.
Oh, thanks.
Super. A quick comment. There's a project coming up that I think will involve Hydronet and our geographical sciences, agriculture colleagues, that the Maryland Climate Change Commission is just about to recommend a study on nitrous oxide. That anthropogenic sources are about the same as natural, and agriculture is the major anthropogenic source, and flooding is critical to the partitioning between N2O, dangerous, N2 harmless. So it's another way we can serve the state.
I'll write that one down.
Any other questions or comments?
I got my right hand raised. I have my hand raised.
I have a question, but for the, oh, sorry.
It's online.
Oh, online, okay.
It's an online question? Yeah.
Okay.
Yeah. So go for it.
Okay. I have a question, but for the purposes of my article where I need to quote 3 people, could I ask you, how has the funding cuts from the current administration, do you have, what is the plan to deal with that going forward, or is there a plan, and how much has it affected your operations?
Yeah, I mean, I'll comment. I mean, Tim might actually have something he could say more, but so part of this, the concept for these grand challenges projects are to try to sustain activity to, which would include writing proposals to external sources. And Tim spearheaded one that got selected, but then when under the current administration, it was deemed not a priority topic anymore. So it is a challenge trying to go after certain open competitive projects that maybe the emphasis has changed. So that is a challenge. So we are looking for other opportunities. They could be more state-based types of things, but I don't know if that answers your question. I don't know if Tim, you want to comment on that at all, or did I capture it okay? Yeah, so it is a challenge. It is a challenge. There's less opportunities, I think, out there that focus on climate resilience right now.
So we're also receiving funding for the Hydronet from Maricus. Mike said it twice, so I won't spell out the acronym. And so far, the Maricus leadership feels fairly confident that that funding will continue. So they've been working very hard on Capitol Hill to make the case for flood monitoring, that it's important and should continue. And so, as I said, so far so good, but things we know can change rapidly, but we're hopeful.
Peter can unmute himself online.
Do you want me to stop sharing?
No, but. He's unmuted, you can go. Yeah, Peter, you can ask your question.
Yeah. I guess it's a combination of rant and some questions, but we think a lot of funding attention spent on defining the problem, but for years, if you went down to the beach or something, you would see that high tide, the water's coming up, and so but very little, it seems, is being spent on actual solutions, I guess. And we're training our AI and feeding it every single piece of agricultural research that exists, but most of the research is not in a form that's useful to farmers. And I don't know, is your organization maybe willing to kind of step up to the plate and go a little bit further on the solution side? Because I mean, you talked about these weather monitoring systems. We use little $5 weather monitors, and we're mapping, like in vineyards, the microclimates every couple of feet, because that's the reality of the effect of maybe climate change and the remediation that has to be done. We're focused right now on golf courses and vineyards because they're so heavy users of preventative pesticides. But would you like to be open to work on solutions like that if we could, say, eliminate all pesticide use in Maryland?
Well, so one of the reasons I'm actually part of this project is my background is that I do co-produce science, where I go and ask stakeholders, what's the problem? How can we solve it? So yes, I do work on agricultural tools and I work on climate tools, but it's always I've talked to a segment of the population, and this is what our network does, is we go talk to a segment of the population and we find out, like everybody knows it's flooding coastally, right? So we know there's coastal flooding in the bay. We know the relative sea level is rising. That's great and everything, but if you go talk to the emergency managers in Annapolis, they want to know when Compromise Street is going to flood. They want to know, can you give me a 6-hour lead time? Can you give me an 8-hour lead time? Right now, I only get 2 hours from the Weather Service. So that's the kind of things that we're trying to do, is enhance warning times. We're trying to enhance so emergency preparedness.
Okay.
So what you're proposing is exactly the type of project that we are interested in, is coming in and working with a stakeholder or user and
Okay. Well, I have the
using,
Revenue Authority we're working with now, that has 9 golf courses and a vineyard. But I think your focus is more on providing the tools to do this, and what we think is not bypass the tool and directly impact something, so that when the warning goes out, the call goes down to the local fire station or whoever the emergency response, as opposed to requiring an intervention of a human to use the tool. And that's where I see that the whole system sort of falls apart. Is that
so,
farmers have all this information and tools, but they can't. They're not usable, I guess. On the
so
things that
actually, yeah, there's a lot of research on that, and that's why, I mentioned it briefly maybe, or Ralph did in my bio. The DW, it's dawn.umd.edu. That project is USDA funded, but it's from a stakeholder standpoint. So we went out and interviewed farmers. Okay, so everybody has a GDD tool. How can we make a GDD tool? What information would you like to see on it? What can we do that's different? We've worked with them on how can we display the data, what data do they want? So that's the type of thing we do. So as far as the alerts go, for our Hydronet system, we are building in, working with the community, like, you'll get a text message at 2 a.m. that says you're hitting a critical threshold. Being a non-federal entity, we're not, we can be sued, is basically what it comes down to. You can't sue the Weather Service for a bad prediction, but you can sue Mike Maddox at the University of Maryland for giving you a bad prediction. So we don't necessarily say a prediction or forecast, but we can give you tools that say, we can see the water rising on a sensor that's, 3 of them in your community, and we can send you an alert that says, hey, the water's rising, go check it out. And we can do that, our data is real time, so we can make that happen. We can turn that around to you in less than 15 minutes from when, the water hits a threshold till you get a text alert or something like that. So we're kind of in a weird little box there where we have to make sure we, cover ourselves.
Sure.
Comes to forecasting and prediction.
Yeah. But I just thought the golf course superintendents, the farmers I talk to, there's all these tools available, all this data, and it's just they don't have the time, or they don't have the language,
So one of the extension agents that we work with in Illinois, he said farmers have 55 things they need to do in a day. And if you bring them 56, they're not going to do it. But if you bring in a tool that makes it 49, they'll use it every day. So that's kind of where our guidance on some of our research is, how can we make your life easier as an emergency manager or farmer or water quality specialist or whatever your thing is, whatever you're doing.
Yeah. Okay.
So we are sensitive to what you're talking about, and there is a lot of research that says that there is a lot of tools that are made in a laboratory or the university that are made from a scientist perspective and not from a user perspective.
Yeah. Well, even just the paradigm of tools is, we've got AIs here. We talk to like Jarvis, like Iron Man, and and we think that's the future, and that's the technology's here. It's not like it's in the future somewhere. Just I'm sorry for taking the time to rant, but my assessment of agricultural research, at least, is that they're all using deterministic physics approach of let's narrow the thing, but living things, the number of things that impact, it's not just the weather, but there's wind, dry air, the expression of genes in the crop. You can have the same genome, on 2 sides of the field, and you'll have different plants. So it's to me, it's much too complex of a problem to assume humans can really do it well. And so when we're hitting up, to the point where, there's going to be food shortages. There's a documentary called Grab. I recommend everybody watch it, where the water resources that grow food are going to be most of the global conflicts, in our future are going to be over that. So this is a very hard problem to solve, and I just trying to get some cognition on maybe taking a different approach to make a serious impact. Say like eliminating pesticides. Why not? Why not just focus and do that as opposed to pass or hopefully pass legislation. But they got Robert Kennedy to shut up about pesticides. So, but I'll shut up. I apologize for ranting too much.
So I'm going to apologize to the previous questioner for asking a kind of a science question, but here we go. So you've got all these observations. You've got them on land. You've got them in the atmosphere. There's also the observations in the estuary. What's the potential to put this all together within like a regional Earth system modeling framework with data assimilation to maybe learn a bit more about these complex interactions that might be crucial to understanding how the whole system responds? Like for instance, there's severe weather in one part of the state. This is going to mean, an anoxic event in the Chesapeake sometime later in particular places. Thanks.
Yep, so that's kind of gets into that satisfies the scientific curiosity, but not something like that doesn't necessarily satisfy a stakeholder. Doesn't necessarily, satisfy somebody sitting in Charles County wondering whether or not they should close some streets or looking at urban heat islands or something in Waldorf. So it's one of those things where you have the scientific curiosity, which we can't help ourselves. We're at a university. That's what we do, right? That's why we're scientists. That's why we did this. We didn't, sign up for this just for fun. Or maybe we did sign up for fun, but I mean, we signed up to do science and do the rigorous work of that nature. But sometimes, and like the previous person pointed out, Peter pointed out that to be effective at the stakeholder level, you have to have stakeholders involved from the very beginning. And they have to lead your design and your concept because you have to deliver information on a spatial and temporal resolution that they can use to make a decision. And you need to do something that makes their life easier. If you make something that's complicated for them to use, they're not going to use it. We presented to one of the Maryland Agriculture Commission meetings. Somebody was presenting an idea, and the one conclusion that they all made was that if it doesn't work on a cell phone or an iPad, they don't want it. So if it doesn't work on a cell phone or iPad, stakeholders probably do not want it. Yeah, it's not not an unworthy pursuit. It's just kind of outside of what we do or what we try to focus on.
So very quick before I actually ask my question, this website does not work at this moment, but that's all right. But what I really want to ask you, so you presented the network really, which seems to be a connection of very nice projects, each one of which individually seems to be very important and could be very useful, although I don't do the applied side of things, but I trust you on that. Could you provide any example where belonging to this network makes a difference? That is, kind of makes those individual projects more impactful in some way, or any kind of coordination? Because kind of what is the added benefits of being compared to having this happening individually?
And so really the purpose of the network is to connect scientists and the science being done at the University of Maryland with the community stakeholders. That's pretty much what the provost told me directly to my face is get them out of their ivory towers and get them into community solving problems at the ground level. And that's what Dr. Pines will tell you as well. So it's, what can you do to help the community is what we're looking to do. So like Dr. Prestegard's work, she's working directly with Frederick in the Greenbelt, looking at stormwater infrastructure and the precipitation changes and how this is affecting their stormwater management systems and their aging systems. So, you know, Frederick, they put in a waterfront park so that when it floods, it just floods a park instead of streets and homes. Other places put in concrete and walls, and that doesn't really work. Ask Ellicott City. So a lot of our. I'm from Columbia, so. Ahead, Dr. Prestegard.
I was just going to add something on that. Someone suggested that we collaborate more among our different groups. And I think one of the things that we're finding is, for example, a lot of people saw this summer that very intense storm events. I measured in the last year 9 short duration storm events that exceeded the projected NOAA Atlas 1400-year storm. And that's kind of the changes we're seeing in precipitation. I suspect the people monitoring precipitation across the state are seeing things similar, but we can now connect those with the rapid rise times of these small tributaries that we're monitoring, and then connect that to the flooding of roadways, and that can be mapped out. So I think there's things that can provide direct applications for people, and maybe make some fairly inexpensive investments around the state to provide more data of this type as well.
Thank you. Oh, actually, it's 5:32. It's 5:32, so we're going to wrap up. Thank you so much for attending in person and online.
Is there any more questions?
There's no more online questions.
One more hand up.
I thought that was from.
Oh,
Peter, do you have one more question?
no, never mind. Yeah.
Okay. Okay, thank you for attending, and join us next month on October 15th for our next session. Thank you.
The website's not working.